In this video, I'll talk about what a computer program is in terms of code, and I'll describe platform-specific libraries and platform-dependent programs. So a computer program is just a set of instructions that run on a computer or other digital device, like some peripheral like a printer, or maybe a camera, or some watches. At the machine level, the program consists of binary instructions, ones and zeros, which we call machine code. This is often grouped in sets of powers of 2, like 16 or 32, or even 64 or 128-bit now. The machine code is translated to the instruction set of the processor or CPU. Even languages like assembly programming, which we often think of as writing code in machine language, is an abstraction of the actual binary instructions, even though it's a very low-level direct abstraction. Then we have languages like C, which are still fairly low-level, but as programmers, we are further removed from thinking in the machine language at that point. When we get into higher level code, like Java, we think and program in abstractions that are further removed from the language of the machine. But at some point, our code must be translated to run on the machine's platform and CPU to carry out a task. Programs written in most languages often require modifications to run on more than one type of computing platform. So a computing platform is just a combination of CPU and operating system, like Solaris, Linux, or Microsoft Windows. This platform dependence is because most languages require you write code specific to the underlying platform. Popular programming languages, such as C and C++, require programmers to compile and link their programs, resulting in an executable program unique to the platform. And we think of a compiler as an application that converts code that you write in text in the language of the programming language into a CPU-specific code called the machine code. So in this example, if we have C code, it needs to be written and compiled for the particular operating system and processor that it's run on. So we have a Solaris OS C compiler that takes the code and translates it into a Solaris OS binary. The same thing for Linux. It has its own C compiler that has the Linux binary, and the Microsoft Windows C compiler that takes the C code and compiles it to a Microsoft Windows binary. And these binaries cannot be run on the other platforms directly. These platform-specific files, the binary files, are often combined with other files, such as libraries of pre-written code or shared objects, which are also in binary form. They're combined using a linker to create a platform-dependent program called an executable, which can be executed or run by the end user. So the resulting binaries from our compilers are then compiled again and linked to different libraries on the system or other shared objects, and in the end, the output is an executable that's only run on its particular platform. Again, so the Linux executable is not run on the Windows computer, and the Microsoft Windows executable is not run on Linux. When we have a platform-specific executable, it is run only on the platform it has been built for, so the program is platform-dependent. So if you want a user to be able to run on multiple platforms, you often need to make changes to the code and to compile a different version for each platform. Unlike the C and C++ compilers, whose resulting binaries and executables are platform-dependent, the Java programming language is a platform-independent language. Its resulting programs, its class files or bytecode, can be run on any platform that supports a Java virtual machine or JVM. And that's one way Java sets itself apart from other languages. And that concludes this introduction to computer programs and platform dependence.